Hi guys, in our previous lessons we were looking at the properties of water, so adhesion, cohesion, viscosity and surface tension, and now we'll be looking at a practical investigation to see how it works in real life. The aim of today is to compare the surface tension and viscosity of water with ethanol and hexane, and to do this we'll be looking firstly at the surface tension. So we need to get clean droppers and place a drop of each liquid, water, ethanol and hexane, on the surface of either a clean glass slide or the surface of paraffin blocks. Then we will observe which liquid has the greatest tendency to form rounded drops. Rounded drops indicate high surface tension. And then repeat the experiment with water again, but to the water we're going to add a weak detergent. So instead of being pure water, which we will be adding a detergent which will give us hopefully a different observation. They'll observe what happens with the detergent, and then finally we'll try to float staples or steel paper clips on the surface of the three liquids. And this is kind of similar to when the insects are walking on the water and to show us really high surface tension or not. The next thing we'll be looking at is viscosity. So remember, viscosity is the ability for the liquid to flow. So we need to fill a burette with 20 mils of liquid and let it flow out of the burette into a beaker and time it. So then we'll repeat the procedure with ethanol and hexane, making sure we use the same burette. If we don't use the same burette, then it might change the amount of flow. So really, we need to be the same and consistent to test when we're doing experiments to test things. Then we'll compare the flow time. So the amount of time indicates to us how viscous the liquid is. Typically what we'll expect when we do this experiment is that water will form rounded droplets on clean glass and wax, but the other liquids don't, because remember, water has very high surface tension and cohesive forces, so it's going to pull it all together and keep it into a round sphere shape. But the other ones have mostly dispersion forces involved, and this means that it's not going to have very high surface tension and cohesive forces. Detergent lowers the surface tension of water, so it forms a film rather than droplets, because it's interacting with the water and breaking up those intermolecular bonds, and that means it can't have the strong bonds it usually has that will give it high surface tension, and that's why we're getting rid of it and making it into a film rather than droplets. Finally, hexane flows faster than water or ethanol because it has a lot less viscosity. Hexane has dispersion forces, so that means it's going to be able to flow a lot better than ethanol, which has a bit of dipole-dipole forces, and water, which has hydrogen bonding. So here we're just demonstrating that water has high surface tension and high cohesive forces by giving us rounded droplets. Detergent can break up these forces, making it form into a film similar to that of hexane, and that hexane has the lowest viscosity because it's the fastest one to come out. With that, we can just do a few questions to see how we're going with what we understood. Firstly, question 12. The diagram here shows one way to compare the viscosity of two liquids. So it's similar to what we just did with the flow rates. Equal volumes of the liquids are put into the separating funnels, and we time how long it takes for the liquid to flow out. So in this one, we need to identify which liquid has the higher viscosity. So diagram A, we put the water in. At a certain time we stopped it, and it flew out quite quickly because we have quite a lot of liquid at the bottom, compared to B, where most of the liquid is still in the separating funnel and we have very little liquid in the bottom. So this means that A flows quickly because there's a lot there in the same amount of time, compared to B, which flows quite slowly. So that means B is the one with higher viscosity because it's flowing quite slowly. So question 13, in an experiment to compare the surface tension of water and a very dilute solution of water and a detergent, drops of each were placed on clean glass slides. What would you expect to observe? And explain the observations in terms of intermolecular forces. So this question we need to answer two parts. We're going to say what we think will happen, and then explain why we think it's going to happen. So the water droplets will form well-rounded spheres and stand high above the glass surface because remember they have strong cohesive forces. The dilute detergent solution will form a thin film on the glass rather than a drop because it's interacting and breaking up these forces. So the detergent is going to lower the surface tension of the water, and the drop is going to be flatter because we're interacting and breaking up the intermolecular forces that are usually quite strong. So the detergent is a surfactant. It interferes with the hydrogen bonds that holds the water together. But adhesive forces between the glass and the detergent solution are now stronger compared to the water ones, and therefore the detergent solution will spread out over the glass surface because it's able to bind and interact with the glass. So next, question 14. A, describe the trend in the surface tension with increasing temperature. So as we increase the temperature from 10 to 30, we're getting the surface tension values decreasing. So what is that telling us? It's telling us that the surface tension decreases as the temperature increases. So why is this happening? We need to explain this trend. At higher temperatures, the water molecules have greater kinetic energies because we're putting in energy in the form of heat. This is absorbed by the water molecules. They bounce around a lot more. And the greater molecular motion acts against the formation of hydrogen bonds. Because I'm moving a lot, it means that the bonds can't really form. So the water molecules slightly further apart, and so the attractive forces between them are getting weaker as we move further apart. So question 15, consider the information below in the table and order the substances in terms of increasing strength of the intermolecular forces. So intermolecular forces, remember, are the ones between molecules, and usually the trend is if we have high intermolecular forces, then we're going to have a higher boiling point. So first of all, water. Water has the highest boiling point. Then the next one is the -10, sulfur dioxide. After that is the -33, ammonia. And then finally the lowest temperature here is the methane. Question 16. Explain in the order in terms of the nature of the intermolecular forces involved. So methane only has dispersion forces because it's non-polar, remember? So these dispersion forces are quite weak. Ammonia and sulfur dioxide are both polar molecules because remember there's lone pairs that they're pushing the atoms down, making them into a bent shape and a pyramidal shape. So while ammonia has hydrogen bonds, which must be overcome between molecules, sulfur dioxide is a larger molecule, and so it has more electrons, and that means the electron cloud is quite big, and that means it only really has dipole-dipole forces involved. So the dipole-dipole forces are stronger than the hydrogen bonds in ammonia because there's quite a lot of them. Finally, water has hydrogen bonding, like we know, and this is occurring between molecules, and it is the strongest intermolecular force compared to the rest of them because it has the highest boiling point. So when we're looking at this, we're looking at the intermolecular forces and how this influences viscosity, so flow rate. We're also looking at how it can change the differences in boiling point and melting point. So stronger forces mean higher of those temperatures. And then we're also looking at surface tension, so the ability for cohesive forces to be quite strong, and we can look at whether they form spherical droplets or thin films.